The next super important bit of circuitry is the register file. And as a big picture, the register file is 4 sets of 8 flip-flops. And so each register stores 8 bits. And so the register file just stores 4 registers, at least ours does. And as inputs, it's going to have 4 different clocks, 1 clock for each register, because you're going to want to be able to choose which register to write to. And you want to be able to write to them independently of each other. You're also going to have an input that's going to tell you what to write. And then you're going to be outputting the registers constantly. And so here we have each register is here. And so when a specific clock for a specific register goes high, so if we want to look at register 1, when clock 1 has a positive edge, we are going to load in the 7 bits into here, and it's going to update them and onto the output. But because our clocks are gated and we're not updating all of them at the same time, these ones will not have anything on the clock. And so even though they have them on the inputs, even though they're on the inputs here, the outputs are not going to change, and the outputs are just going to stay the same. And so that allows us to change our registers individually. And each register looks like this. It's just going to be a set of 8 flip-flops. And all the 8 flip-flops are connected to the same. All the 8 flip-flops are connected to the same clock. So when the positive edge of the clock comes, they will all update at the same time and all change the output at the same time. Some considerations for this are fan out. And we really care about this because we want our clock signal to be super strong. But because we are connected to so many different individual circuits here, we can have some trouble driving these. So what we need to do is we often need to put a current buffer. So that can just be a series of inverters. A series of inverters like so. And that'll give us like 3 to 1 or 3i for 1i in. And that can allow us to drive this register file much better. Because if we don't do that, instead of having a nice looking clock signal like this here, we'll have something like that. And when that happens, we may either not capture the positive edge at all, or we may just have it mess up. Maybe this is VM, and so it never gets above it, and then you're never able to actually update your values in the register file. And looking at the circuit overall, we have the register files are outputting to the ALU and the SRAM all the time down here. And so that just means that whenever they're needed, they can be used very quickly. Another important thing to note is we have a couple of gates going on the clocks into the inverter or into the register file. One of those will choose us, one of those gates or series of gates. This one here will be saying, can we or can we not write this? And then also, which register have we selected? So if we select register 1, that'll be green, but that'll be high, but the rest of these will be low. So no matter, even if we're writing, these will all be low. So if we are writing, this will be green. And because this one is green and it's an AND gate, we are just essentially gating the clock to allow it through whenever it comes. And so that allows us to pass through the clock, allowing us to update the register whenever we need to. Oh, and an important way to simulate this would be, first you want to make sure that each of your individual flip-flops is working. And then you're going to want to make sure that you can get them to all work together. into one register file, into one register. And then you want to make sure they all work together as a register file. And you can just do that by setting them all initially to 0 and then loading in ones, and trying to make them work that way.